Morning. Okay, so let's go to page 2. You've got your basic angles, and I'm just going to briefly talk about them. Acute is less than 90. Any angle that's less than 90 is acute. Obtuse, anything that's greater than 90. 90 degrees. Your right angle is denoted by a box. It is a 90-degree angle. A straight angle is, this one is often, I call it, I would say this one is not as valued as it should be. So when you have a straight angle, you can cut that line anywhere you want. And if you measure from this side all the way to the other side, you've got 180 degrees. But so it's like a hat, right? Like an RCMP hat. But just keep in mind, you could also have a slanted line and cut it and still have a 180. Okay, so you might have a straight angle going in a diagonal, but still that line in itself has a 180-degree angle. Reflex is greater than 180. So you kind of want to do something like this. If you measure from here all the way to there, it's greater than 180 degrees. However, let's review the one that I'm not talking about here. If this had been 200 degrees, let's say, this angle right here, what is this one inside? What's a full circle? 360, right? If this is 200, then this is 160, all right? So sometimes we want to use that as well. If I give you this, you can find the rest, which is 160. Okay, so keep that in mind. I'll just say a full circle has 360 degrees. Okay, so just so you remember, it's going to come in later. Then we've got complementary and supplementary angles, and this is always true. And I will just say that to know complementary, just think of it's right. It's the right thing to complement someone. So complementary, you think of a right angle, so it's 90. It's two angles that add up to 90. So I will show you here. If this is 20, then this must be 70. Okay? So to get angle Y, in this case, we would just go 90 minus the 20 degrees, so that's 70 degrees. Okay. Again, this is the kind of way we're used to seeing a complementary.
Interruption. Unity Goodman Center 61, please. Unity Goodman Center 61.
But let's draw an upside down, right? If this had been 30, and you know that there's a 90 happening here at that corner, if this is 30, then this angle here is 60. So they're still considered complementary as they're depicted there. Supplementary, angles whose sum is 180. So technically, if this is 30 degrees, then this one on the other side is 150, right? And again, you've got that straight angle here, and so we know that when they're side by side they're 180. Similarly, if you have them if you have a slanted angle right here, and if I were to cut this here, and you realize that this is 40, okay, then this must be 140. So it's just like a conclusion you can draw when you have a straight line and another line comes in and cuts it, okay? And then of course, if you consider this point of intersection right here, there's an angle there, there's another angle here, and we know that all three angles here must add up to 180. So to find angle X, we just go 180 minus 31 minus 24. And that's 125 degrees. Make sure you use the degree symbol whenever you're finding an angle. And I like to, especially when there's a lot going on, I often highlight the straight angle, right? I highlight the straight angle, because then you're like, oh, okay, there's that, right? Along that orange line, in this case, I've got a 180 degree angle, a straight angle. And I'm going to add, I'm going to use a shortcut. I know we skipped it here, but if you look up here where my pencil is hovering right now, the shortcut is, I will just go straight angle is 180 degrees. Why am I introducing some shortcuts is because this unit is going to require you to justify why you came up with angles that were missing. Okay, and so that is the shortcut for straight angle. Let's keep going. Vertically opposite. So vertically opposite angles are congruent, they're equal. So the word congruent is maybe new to you, but it just means that they're equal, okay? So vertically opposite in this case, if you see two or more lines being joined, if you consider that point of intersection, then technically there's a pair of vertically opposite here and a pair of vertically opposite right there. So this angle and this angle would be considered vertically opposite. Okay? So if you want to call this angle X and this angle Y, okay, angle X would equal angle Y because vertically opposite angles are congruent. So here I'm gonna introduce this symbol to you. In math, we're lazy, okay? We don't like to write a whole lot, so we use symbols if at all possible. So that is congruent. So you can use this symbol, you can write it over top of congruent. So it's an equal sign with a third squiggly line on top. And guess what? We have another set of vertically opposite. This one here and this one here would also be considered vertically opposite. I'm just going to call this angle K and angle M. Doesn't really matter what letters you use. Angle K is equal to angle M as well. Same reasoning. Same reasoning. So what you just have to make sure is when you make this kind of decision, if you want to trace these two lines, right, like you realize these two lines, if I continue on them, they continue here. So these two angles are vertically opposite. If you want to consider these two lines and they cross, then you've got the vertically opposite. So these are equal to each other and these are equal to each other. They share the same two lines. Okay, so that's how you recognize it. Why am I saying that? Because it can get kind of crazy here. As you can tell, there's a lot going on here. Let's identify one pair of vertically opposite. This angle right here would be vertically opposite to this angle right here. So we can have a little side note here. Angle y is equal to 29 degrees. And I'm going to use the shortcut vertically opposite angles are congruent. Vertically opposite angles are congruent. I also noticed that angle x is across the 35. They're vertically opposite. I can guarantee you they're going to be the same. So angle x is equal to 35 degrees. Again, vertically opposite angles are congruent. That's my justification. And how can I find angle z? Or z, yeah. Supplementary, yes. Supplementary. So it doesn't matter where you want to see the supplementary. I'm going to travel on this line right here. If you consider that straight line, you've got a 180 happening there. So yes, Z doesn't have a vertically opposite. That might not help you here. But if you consider this straight angle right here, you know that it has to be 180 from end to end. So we can subtract these two from 180 degrees to find that one. So I'm going to do that. Angle Z, I'm going to actually show my work here, is 180 minus 29 minus 35. Angle Z is 116 degrees. And I'm just going to use the reasoning. Straight angle is equal to 180 degrees. So I've found all missing angles, and I specified how I came up with that. Okay. Okay. Another one. What would it be all around? If I added up all angles all around, it should add up to 360. Right? So that's always there for you if you want to find out. But we know that this one would be the same as Z because they share the same two sides. So now that we found Z or Z, we can find this one. Okay? Let's keep going. The sum of interior angles of a triangle is equal to, what do all angles in a triangle always add up to? How many degrees? 180 as well. So 180 is kind of like a theme here. So the shortcut for this property is going to be sum of triangle is equal to 180. You're welcome, right? I just make those ones up because I don't want you to have to write a sentence every time. So if you see this, I would definitely add this to my study sheet. Right? Sum of triangle is equal to 180. That's one of the properties. So what we're saying with it is this. Right? Why is that going to be helpful? If this is 30 and this is 70, and I ask you for angle X, right? You should immediately say, okay, there's two angles. If they're inside a triangle, so I'm just going to take away the two angles that I know from 180, and that's what X has to be. And so that's what, 80 degrees? And this is my reasoning. Sum of triangle is equal to 180 degrees. This is my justification, explanation as to how I got it. Next, the sum of interior angles in a quadrilateral triangle is 3 sides, quadrilateral, 4 sides. So anything that has 4 sides is going to be equal to, what do you think? 360. Think of a square. 90, 90, 90. right? 90s all around. 4 times 9, 360. It's going to be 360. So it doesn't matter what it looks like. It could look like this. Okay. It could look like this. It could look like this. Right? It's always 360 inside. If you add up all 4 angles, you get 360. Okay. So the shortcut, I kind of used up the space, but I'll just say sum of a 4-sided shape is always 360. This is going to be my shortcut if I use this property to justify my work. Okay. Should probably highlight those. And I don't know, you might need a diagram, you might need an example next to each one of these shortcuts. Okay, I'm going to go back once to page 2 real quick and just highlight the straight angle shortcut. This one right here. This one right here on page 2. Got it? So you might have to have a diagram right next to it to remind you, to help you. Because remember, you're building this for a couple months down the road, right? Like when it all comes back. Another review here is 3-letter angle notation, which is annoying. I don't like this notation, but you need to know it. Okay, you need to know how to deal with it. So for example, let me see here. I'm going to use letters strategically. This is why we need to sometimes refer to 3-letter notation. You can't just say angle D. Hey, find angle D. What are you talking about? Are you talking about this side or are you talking about that side? What are you talking about? You can't use D by itself. So you have to use the 3-letter notation. So let's call this one X and let's call this one Y. And I'm going to use Z up top here, and K on this side. So it's okay to use letters inside the angles like this. Why am I focusing on this? Because B, there's a conflict. There's 2 angles that are at B, and there's 2 angles that are at D. So if you wanted to refer to angle X, let's do that on this side. Angle X, we would use the following notation. It could be angle ADB, right? ADB is one way to do it. Or you could go BDA, angle BDA. And I will tell you something, okay? Let's go backwards. Let's pretend I started with this. Like, hey, find angle ADB. And you're going to go to your diagram and try to figure out where is it. So I just encourage you to copy this, like go in that order. Go from A to D, then to B. And keep doing that a couple of times. And then you realize, oh, okay, it's at this corner. So it's the angle that connects these segments that you've created. That's the one I want. So I would encourage you to assign a letter to this and put it down on your diagram. Like if you want to call this X, go there and be like, okay, from now on, I'm not going to worry about this anymore. I'm going to call this X right under it and put it on my diagram. And now I can just say that's angle X that I'm looking for. You're not always having to find it again and again. Okay, so angle Y. If I wanted angle Y, I could go BDC, or I could go backwards, CDB. And you notice that both of them have D in the middle. Okay? Can I ask you to try angle Z up here and try angle K here? So come up with the three-letter notation, the two versions of it next to each other, okay? I just need a little, let's see how you did. So for Z, you would want to use ABD. Notice that it's angle. Sometimes you'll see triangle ABD, like there'll be a triangle symbol in front. We're talking about the whole triangle. This is angle, right? Or you can actually just read this backwards, DBA, right? DBA. K, DBC, or angle CBD, right? C to D to B. No, sorry, C to B to D. Okay, so there you have your three-angle notation to identify that angle specifically. Okay, next. I want you to find, this is practice, okay, so copy this down. I want you to find the angles as a number for the following. So copy these down, these angles, and before we answer, let's together fill in more numbers. You can have way more more numbers than are visible right now. I love using vertically opposite angles every time I see them. Okay, so let's try it. If this is 83, then this is 83 over here, correct? Vertically opposite. If this is 103, this is 103. If this is 77, then this is 77. If this is 97, then this is 97. So you found, at all four intersections, you found additional angles just using the vertically opposite. What else can I use at every intersection? I know that this is a straight angle, so this must be 97. Why is that? Because 97 and 83 add up to 180. So if this is 97, what's this? 97. Why, Mr. Dixon? A bunch of reasons, okay? A bunch of reasons. Why? These are vertically opposite. That's reason number one. What are these two angles here? These two right here. They're supplementary, right? They're along a straight angle. That's another reason why. And a third reason. What do all four angles, what should they all add up to? 360. So now I have three reasons. The more you find, the more reasons you have to find the one that's missing. Okay? Let's do the same thing here. This is 97 and this is 83. So is this one. If this is 103, then this is 77. So is this one. I'm just making sure they add up to 180. If this is 77, then this is 103 because of the straight angle. Then this is 103 because of vertically opposite angles being the same. So now you've got a bunch of numbers all over the place. Please now try to answer these ones here. If you're still stuck, I'll do the first one with you. GKC. I go find it. GKC. GKC. So this is where the segments are created. You're combining those two segments. And 83 is your answer. So this should be 83. If you're still stuck, I'll do another one. BAE. B to A to E. Look at the two segments that you're creating. You're creating this segment and that segment. You're going to connect the two. And it's that angle that I'm talking about. So BAE is 83 as well. Try the rest by yourselves. Now you're awake, or not. Anyways, LFD. LFD, it's 103. KHF. Where are you, K? KHF. So watch out. K to H and then to F, right? These two segments are the ones you're connecting, so it's 77. AFH. AFH. So you're connecting these two segments, that's 103. AKH. Where are you? AKH. It's 83. So make sure you correct it, right? KAF. KAF. You're connecting those two, so that's 83. So there you have it. That's how you do it. Let's keep going. Trust me, we'll do this again, so it's not going to be the first or last time.
Excuse me for interrupting. Can we please get a custodian with a trolley to room 61? Custodian with a trolley to room 61.
Is there a room 67 at Sisler? There's. Must be cool to have that room. Maybe one day 88 will be the new 67. Anyways. Fill in table below. Justify your answers. I'm going to ask you to, I'm going to pause on this and ask you to do it later, okay? So for now, we'll say homework, even though your homework for tomorrow is like, don't worry about this. You'll just continue. I want to talk about these other two concepts here. Parallel and transversal lines. Highlight that. So you need to know what parallel lines are. I think you already do. Two or more lines, right? Lines are parallel if they never meet or intersect. You can recognize parallel lines when the symbol in the form of an arrowhead is visible on two or more lines. Okay, there's this symbol there. That's on a diagram. Okay. If you want to just talk about if I didn't put those symbols there, I would just say AB, segment AB is parallel to segment CD. Okay? I'm saying that these two lines are parallel. How do we know? They both have one arrowhead somewhere in between. You can also say that EF is parallel to GH. Okay, so either statement is true. They're both true, in fact. Okay, and I'm going to use different colors because, right, these are parallel, and these two are parallel. Pink is running out. Might have to restock my pink highlighter. Get a new one. Next, the transversal. A transversal is a line that intersects two or more lines at distinct points. Note, a transversal line can also be parallel to another line. That's our big note here. A transversal line can also be a parallel to another line. When a line is referred to a transversal, we know that along it we can find four distinct pairs of angles. I'm going to use a different color for this. Four distinct pairs of angles, and I will already give you a heads up on that. By those four, I mean consecutive interior, angles, corresponding angles. Write this down so that later when you review it, it just pops and you should recognize it. Alternate exterior angles, alternate interior angles. Those are the four that you will find every time there's a transversal. In this case, I'm going to focus, I know you're still copying, in this case I would focus on this being my transversal, okay? Because it cuts through two or more lines, so that's the one I'm focusing on in this diagram here. And here are the four pairs I'm going to show you on the next page, on page 5. How do you identify them? Where are they located? So go to page 5. And there they are. I'm going to zoom out once. You've got corresponding, alternate interior, alternate exterior, and consecutive. Make sure you have these on your study sheet. Have a small version of this on your study sheet. Okay? So I'm going to start with corresponding. If I ever talk about corresponding angles, okay, and you focus on this transversal, this is the one you're traveling along. Let's keep orange. Let's keep highlighting that orange. If that's the one you're traveling along, one pair of corresponding angles would be this one right here. Highlight that one. One would be corresponding to 5. I'm not going to highlight them all because then they're going to be hard to see, but 2 and 6 would also be a pair of corresponding angles. Okay? As well as 4 and what? 4 and 8 would be one pair of corresponding. 3 and 7 would also be a pair corresponding. So what I'm going to do here, I want you to draw this the other way. So imagine you've got two lines like this and one that cuts across there. I want you to have a diagram that is kind of not the conventional way. So you could also say that this one corresponds to this one. It's the same thing. Yeah.
How does 4 and 8 correspond?
4 and 8? It's kind of like this pattern. Look at the two lines that it cuts, right? One is outside, one is inside, meaning between the two lines. And they're both on the same side of the transversal. So,
Does like see the lines that are a little different? Like,
no, we call, it doesn't matter what the lines look like. This one and this one are called corresponding. 4 and 8 are called corresponding, and so forth. That's the pattern. So I will tell you the pairs in case you need to know for sure, right? 1 and 5, angle 1 and angle 5, angle 4 and 8, angle 2 and 6, angle 3 and 7. So you always have 4 pairs. Alternate interior. Okay, couple of things. These 2 lines that are being cut across by the transversal, this area here, this area is called interior. That means that this is exterior and this is exterior. So if it says interior, where are the angles going to be located? They're going to be somewhere in here, in between. I call it the bun of the burger, right? The buns, right here. So 4 and 6 would be considered alternate interior. And I'll tell you here, pairs, angle 4 and angle 6, as well as 3 and 5. So there's only 2 pairs. And I'm only highlighting one of them. So you're, like, if you do this on your study sheet, you should be able to recognize, oh, that's the pattern. Let's draw one that's sideways. Let's turn this sideways, and you have a transversal like that. You just have to recognize that this angle right here is going to be alternate interior to that angle right there. I should have zoomed in a bit, but I wanted you to. We good? Okay. The other 2. Alternate exterior. Okay. Again, this is interior, which means this is exterior. This is exterior. So where are these angles going to be located if it says exterior in the name? They're going to be on the outside. Okay? So I'll tell you one pair. 1 and 7. That's one pair. Which one do you think is going to be the other one? 2 and 8. Okay. So pairs that fit this criteria, angle 1 and angle 7, as well as angle 2 and angle 8. And last but not least, consecutive interior angles. I often refer to these as the CIAs. Okay, consecutive interior angles. Again, if it says interior, that means that they're going to be inside the 2 lines that are being intersected. So this is one pair, 3 and 6. And the other one will be 4 and 5. Angle 4 and angle 5. I want to have a sideways diagram here, like this. And so again, you would identify this one and this one. Okay. That backfired a little bit. It's not a great example, but maybe I'll do this to identify. Okay. those two angles will be consecutive interior. So I would like you to, on your study sheet, I want you to transfer this onto your study sheet, and you don't have to take up that much space, right? Let me see if I don't have a blank piece of paper. If you use a study sheet, right, you could just have, if you call this angles, this is chapter 2, right? You could just have like corresponding. I'm just giving you an example. I'm not going to do the whole thing, but you just have something like that, and you tell yourself, right, that one and this one. Okay, so you kind of know the pattern. And if you need to do a sideways diagram where you have the two lines going like this, right, you have that one and that one. And so forth. You do corresponding, alternate interior, alternate exterior, and so forth, because this is going to be very important for the entire unit. These 4 angles, you need to know where they are, okay, where are they located. Okay, keep going. Page 6. Conjectures. Okay, so we can draw some conclusions here. When a transversal intersects lines that are parallel, then all of the following are true. Alternate exterior angles are going to be congruent. Alternate interior angles are going to be congruent. Corresponding angles are going to be congruent. Consecutive interior angles are going to be supplementary. Whoa, what is that? I want you to have this box on your study sheet, but I'm going to give you a little cheat for that it's a little bit smaller, uses up less space. So I'll just say this. If transversal cuts through parallel lines, if you know that that's happening, then alternate exterior angles are congruent. Alternate interior angles are congruent. Corresponding angles are congruent. And CIAs, right? Consecutive interior angles. What does it say about those ones? Consecutive interior angles are supplementary, meaning they add up to 180 degrees. If you can make this smaller, that'd be great. I just want to make sure you can read it, right? Make sure you have this written down, okay? So this is one side of the coin. On the flip side, if I ask you to prove whether or not lines are parallel, if you can show that one of the following is true, if you can show me that alternate exterior angles are congruent, or alternate interior angles are congruent, or corresponding angles are congruent, or consecutive interior angles are supplementary, then lines connected by the transversal are parallel. So look what I'm going to do here. I'm going to give you another here. If our lines parallel, question mark. If you need to show this, right? Show that one of the following, this is following, is true. Alternate exterior angles are congruent. Alternate interior angles are congruent. Corresponding angles are congruent. CIAs are equal to 180 degrees. You can be creative and just have one of these boxes on your study sheet. How can you be creative, you may ask? You could just have like a bracket here and just say, if you need to show whether lines are parallel, just prove that one of these is the case. Just show that one of these is the case, and then you've actually said, you've determined whether or not lines are parallel. A lot of information, I know. As you copy this, maybe you have already, notice what it doesn't say here. If you can show that sum of triangles are equal to 180, that's great. You've done well. You're right. But it doesn't show whether or not lines are parallel. If you can show that vertically opposite angles are equal, that's great, but it doesn't show whether or not lines are parallel. If you can show me that a bunch of angles along a straight line add up to 180, that's great, but that doesn't show me that lines are parallel. It's these four, like one of these four that you have to show me that like if you can prove that one of these four is applicable, then you've determined whether or not lines are parallel, okay? So let's go to page 7. I'll show you one example, and then I'll call it, that's it for today, okay? You can review for tomorrow if you want, or try this further if you want. We're gonna jump right into the example here. In each diagram, prove or show whether or not line EF is parallel to GH. Is there more than one way to justify? The answer is going to be yes. But remember, alternate exterior, alternate interior, corresponding, and CIAs. Those are the four that we're gonna prove that one of the four, right? These three, we're looking for them to be equal. The last one, you're looking at the pair of CIAs to add up to 180. Just show me one of the four, and then you're good. So looking at this diagram, what pops out to you? Do you notice that the 67s are the same? All right. Do we have a name for those two? What would we call them if you go back to page 5 and tell me what we would call those? Ranveer. He's saying corresponding. Do we agree? You agree? Okay. All right. So yes. So we can, and so they're corresponding. Let me see, corresponding, and they're supposed to be equal, correct? If they are, we can now say that EF is parallel to GH. Why? So we determined that because of these two, we can tell that EF is parallel to GH because corresponding angles are congruent. It's okay to shorten it, you don't have to write down the whole thing. Is there another pair that we could have identified? What would these two be? What do we call this one and this one? Alternate exterior. And they're also congruent, right? Or, so write down or, EF is parallel to GH because alternate exterior angles are congruent. I'm gonna color match here. Alternate exterior or corresponding. You take your pick. I would argue that there's more ways to justify. There are more ways. Guys, if this is 113, then what's this? 113, right? Vertically opposite. What would these two add up to? These are consecutive interior. What's 113 and 67? 180. CIAs add up to 180, right? Now it's getting a bit too crazy, so we didn't stop there. You made your point right there. Like if you just answered that, you'd be fine. But it turns out that you can actually show that all four of them are true. It turns out that that's the case. But you just have to show me one. We're going to stop there.